Hello all, welcome to Electronic Devices and Circuits video lecture series. My name is B.V. Sachinarayana, Associate Professor from Department of ECE, Vishnu Institute of Technology, Bhimavaram. I will be handling this Electronic Devices and Circuits subject now. In this subject, the unit number 3 is Rectifiers and Filters. In almost all electronic circuits, we need a DC source as a power supply. In general, we are getting DC from batteries, but the maintenance of batteries is very difficult practically. That's why in the electronics, we are trying to convert AC to DC, and the DC it is utilized in our system devices. Here, in the conversion of AC to DC, there are three very important blocks: rectifiers, filters, and the regulators. But our syllabus, it is not included regulators. So the unit number 3 is rectifiers and filters. I will start this rectifiers and filters unit with the introduction. The objectives of this video are DC versus AC, how to convert AC to DC, waveforms of regulated power supply at various stages. AC versus DC. So AC means alternating current, whereas DC means direct current. But as per IEEE standards, alternating current is pronounced as AC and direct current is pronounced as DC. So there is a AC voltage, AC current, DC voltage and DC voltage. You never abbreviate alternating current, direct current likewise, okay? Here AC means continuously varying signal, means it varies with respect to time. Whereas on the other side, DC is always constant with respect to time. Okay, that's why in general the AC it is the sinusoidal in nature, which is continuously changes with respect to time. So suppose if you take time on x-axis and voltage or current on y-axis, then the AC signal it is sinusoidal in nature. Whereas on the other side, if you take DC, the DC is always constant with respect to time. So time on x-axis and either a voltage or current on y-axis. So this voltage or current, it is always constant with respect to time. So if you clearly observe the AC signal, then this AC it consists of both positive and negative, and this positive and negative alternatively changes. That's why the AC signal it is bidirectional in nature. Whereas on the other side, DC, if you observe, it is either positive or negative, that depends. Means the DC it is unidirectional in nature, having only one polarity. Okay, so AC it's having both positive and negative, the two alternatively changes, but DC it may have either positive or negative, that depends. That's why for AC there is no need to represent the polarity. This positive and negative continuously changes. But on the other side, DC if you take, it is either positive or negative, means we must represent the polarities. Suppose if you consider batteries, on the body of the batteries there is a plus and minus sign, means it represents the battery must be used like that only. The polarities must be specific, unique. You must not change the polarities. That too, AC it is continuously changes with respect to time, means definitely this AC it is having some frequency. Whereas on the other side, DC if you take, it is constant with respect to time, means there is no frequency. So in general, our AC supply at our home, it is having 50 Hz. Whereas for DC it is 0 Hz. If it is a perfect DC, ideally the frequency is 0. So it is 0 Hz. Okay. So in general, we are getting AC from our supply mains. Okay. So means from power plants, we are getting the AC. Whereas on the other side, the DC, we are getting in general from the batteries. So these are the some of the basic differences in between AC and DC. And in this unit, I'm trying to convert the bidirectional AC signal into the unidirectional DC signal. This is the bidirectional AC. That bidirectional AC I am trying to convert into unidirectional. So for this conversion, we need three very important circuits: rectifiers, filters, and the regulators. And regulator, it is not included in our syllabus. So we will cover only rectifiers and the filters. And as I already told, almost all electronic systems requires a power supply of DC type. And this DC in general we are getting from the batteries. And the maintenance of batteries is very difficult. The two, it is inconvenient to use. On the other side, the cost also very high, expensive. That's why we are trying to eliminate the batteries in our electronics. Suppose TV, if you consider TV, we are operating with AC. Means in that TV there is a built-in converter. That built-in converter converts AC to DC. So in electronics, we are preferring to convert AC to DC, and the DC it can be utilized in our systems. So that conversion process in general, we can call it as a regulated power supply. All those blocks combinedly, all those three blocks combinedly, we can call it as a regulated power supply. Means a regulated power supply can convert AC to DC, and it consists of the following blocks. The very first block is step down transformer. In the conversion, we need a step down transformer, a rectifier, filter, and the regulator. So these four blocks can combinedly convert AC to DC. Okay. So if you are using these three or four blocks, then there is no need of batteries. So our AC mains supply, it can be converted into DC, and the DC it can be used in our systems. Okay. So first I am trying to explain the regulated power supply, RPS. So which is a converter, AC to DC converter. A typical DC power supply consists of various stages, and all those stages combinedly converts AC to perfect DC. And here first I am trying to draw the block diagram of RPS unit, which represent all stages of the power supply. And this is the block diagram. This block diagram, it consists of a step down transformer, rectifier circuit, filter circuit, and the regulator circuit. So the input of the transformer, it is AC mains. Means 230 volts 50 hertz power supply is the input. And here a step down transformer is used because all our electronic systems requires a very small voltages. In general, it is in the range of 1 volt to 40 volts. But at our mains, there is a 230 volts 50 hertz supply, which is very high voltage. So we need to reduce the level to our required level. For that, we need a step down transformer. Because of the step down transformer, the level of the AC voltage, it is reduced. Still, the output, it is a AC voltage. I want to convert the bidirectional signal into unidirectional signal. So we need a rectifier circuit. And that rectifier circuit, it converts AC to the pulsating DC. Okay, means this DC, it consists of AC component. Rectifier circuit, it can convert AC to pulsating DC, which consists of more AC component. Means rectifier, it simply converts bidirectional signal to the unidirectional signal only. That's why the output of the rectifier it is given to a filter. This filter it is trying to eliminate most of the DC component, but the output it is not perfect DC. That's why the output of the filter we can call it as a unregulated DC. There is a very small AC component in the output. That's why the output of the filter it is given to the regulator. This regulator circuit, irrespective of the AC component, it produces a constant output voltage, and hence the output it is close to the perfect DC. And this diagram also represents waveforms at various stages. Suppose the first waveform, if you take, it is a AC signal. So 230 volts, 50 hertz. That is given to the input of the step down transformer. So the output of the step down transformer is the waveform number 2, which is also AC bidirectional, but the level it is reduced because of the step down transformer. So I want to convert this signal to perfect DC. So first convert this bipolar signal to unipolar signal. For that, we need a rectifier circuit. This rectifier circuit converts this bidirectional signal to the unidirectional signal. Means because of this rectifier circuit, this negative portion it may be clipped out. This negative portion it may be clipped out, or this negative it may be converted to the positive. That depends, and hence the output of the rectifier it is unidirectional. So having only positive polarity, having only positive or having only negative. But still the output it is not perfect DC. There is more AC component. That's why this waveform it is given to the filter. And this filter circuit which eliminates most of the AC component. So the output of the filter it is waveform number 4, that is unregulated power supply. Means there is a very small AC component present in it. This unregulated output voltage it is given to the regulator. This regulator, irrespective of this very small variations, it can produce a constant output. So the output of the regulator is perfect DC. It is constant with respect to time. Output voltage or current is always constant with respect to time, and hence all these blocks can combinedly converts AC to DC. Okay, I will explain all these blocks in detail in the coming slides. So first I am starting with a step down transformer. In general, in our electronics, we need a DC voltages, but those DC voltages are very small. Those are in the range of few volts to few tens of volts. So in general, we want 1 volt DC to almost 12 volts DC. So yeah, suppose highest DC means it is just 40 volts. That's all. Nothing more than that. So at our supply, 230 volts voltage AC voltage it is available. That's why that voltage first need to be stepped down. For that we are using a step down transformer. It is must in the power supply. Suppose if you want to increase the voltage to the higher voltages, then we need a step up transformer. But in our electronic systems, electronic circuits, devices, we need a lesser voltage. That's why in most of the cases there is a step down transformer. At our mains 230 volts 50 hertz supply is available, that is connected to the primary of the transformer, and at the secondary we are getting the AC voltage which is reduced to the required voltage for the desired DC output. So in this transformer, the selection of turns ratio is very important. So I want a step down transformer. That's why N1 must be greater than N2. Means there must be large number of turns in the primary and small number of turns in the secondary, so that it becomes the step down transformer, and the AC voltage is reduced to the required level. And this diagram, it represents input and output waveforms of step down transformer. As I already told, the input to the step down transformer is 230 volts 50 hertz supply, which is a very higher voltage. That's why it is given to step down transformer. So for step down transformer, it is reduced to a lower level. Still it is AC. The output of the transformer is also AC, but the level it is reduced to the lower level. Suppose I want plus 5 volts DC, I want, suppose. Then this is reduced to 5 volts. This is 5 volts and this is minus 5 volts likewise. Okay. So it is 230 volts AC RMS value. This is RMS value that is reduced to 5 volts AC because of the step down transformer. So the input of the step down transformer is bidirectional and the output of the step down transformer is also bidirectional. So I wanted to convert this bidirectional signal into unidirectional signal. That's why this is given to the rectifier. The output of the step down transformer is given to rectifier circuit. Step down transformer output, it is bidirectional in nature. We want to convert that bidirectional signal into unidirectional signal. So a rectifier is required. This rectifier is an electronic circuit which can convert AC voltage to pulsating DC voltage using one or more PN junction diodes. Why PN junction diode is used in rectifier circuit means, for this rectifier we need a device that must exhibit unidirectional characteristics. Hence a PN junction diode it is used. The output of the rectifier, it is pulsating in nature, means it is a unidirectional voltage containing a very large amount of AC component. That AC component we can call it as a ripple. So this rectifier circuit converts the bidirectional signal from step down transformer to the unidirectional signal. Still the output is not constant. There is more ripple content in the output of the rectifier. So the output of the rectifier is not perfect DC. If you want more perfect DC, suppose, then filter circuit must be used after the rectifier circuit. And this diagram represents input and output waveforms of rectifier. The output of the step down transformer is given to the input of the rectifier, which is AC voltage, means which is bidirectional, having both the positive and the negative. That signal it is given to the rectifier, and this rectifier uses a diode, and this diode it exhibits unidirectional characteristics. Because of that unidirectional characteristics, this bidirectional signal it is converted into unidirectional signal, means this negative portion it is completely clipped out, or this negative it may be converted to positive, and hence at the output of the rectifier there is a pulsating DC which consists of more AC component. That's why the output of this rectifier, again it is given to a filter. Filter is used for a rectifier circuit, used after a rectifier circuit, which reduces the ripple content in the pulsating DC and tries to smooth the rectifier output, means it is trying to bypass most of the AC component present in the pulsating DC. So in rectifier we need reactive elements such as capacitors and inductors. This capacitor and inductor can separate AC from DC, and hence these two components are used in the filter circuit. Still the filter output contains some ripple component which is very small. That's why the output of the filter we can call it as a unregulated DC. There is a very small amount of AC component present in the filter output. For even more perfect DC, it becomes necessary to use a regulator after the filter circuit. And this diagram, it represents input and output waveforms of the filter. The output of the rectifier, it is given to the input of the filter circuit, which is pulsating DC, pulsating in nature, means which consists of only positive off cycles, unidirectional signal. That is given to filter, and this filter, it uses either a capacitor or an inductor or combination of these two, and hence these components can bypasses most of the AC component present in the input signal, and the output, it is close to perfect DC, close to perfect DC, but still there is some small AC component. That's why the output of the filter, we can call it as a unregulated DC. Still I want more perfect DC, means the output voltage must be constant with respect to time, and hence after filter a regulator circuit it is used. So this regulator, it is the last block in our RPS unit, regulated power supply. So this regulator can give a constant output voltage irrespective of the input voltage variations and load variation. Since this regulator, it is the last circuit which must produce the constant output voltage irrespective of both input and load variations. Since we want a constant output voltage at the regulator output, we need a device that must give a constant output voltage. So a Zener diode is used in the regulator circuit. So this rectifier circuit, which can produce constant output irrespective of both input and load variations. So the output, it is a perfect DC. Output voltage is constant with respect to time. And this diagram, it represents input and output waveforms of the regulator. The output of the filter, it is given to the input of the regulator, that is unregulated DC. There are very small variations in the unregulated DC, and in this we are using a Zener diode. That Zener diode, it can produce constant output voltage irrespective of these small variations. So the output, it is a perfect DC. Perfect DC. Output voltage is constant with respect to time, and hence our AC signal, it is converted to DC, pure DC, perfect DC. So transformer, rectifier, filter and regulator combinedly converts AC signal to the DC signal. And coming to the summary, in this lecture we have learned the differences between AC and DC, and the process of converting AC to DC, and the waveforms of regulated power supply at various stages. In this in the next video, we will discuss what is rectifier and what are the different types of rectifier, and what is the general setup of wave rectifier. Thank you.